All right, this is something you probably learned in Algebra 1. Remember doing the slope of a line? Okay. Slope of a line. All right. So when I think of slope of a line, I think of like a slanted line, like going up a hill, right? Going up a hill, and you want to find out how steep the hill is. So let's I think I might be able to do this. See if I can do this. Yeah, look at that. Okay, so look, that's steeper, right? Then, oops. See if I can do it again. Oh, it figures. Yeah, I got. Oops, no, it's not what I wanted to do. Let's try this again. All right. Now I got. Oh, daggone it. Let's try it again. Click on that. There we go. There we go. So that is steeper than, let's say, that. Would you agree? All right. That's just like horizontal, isn't it? Right there. And that would be what? Straight up and down would be what? Vertical. So they all have different slants. And it could slant the other way, like this. There we go. All right. It could slant like this. All right. So they all have different values. All right. Isn't that kind of cool? Ooh, I could do that all day. All right. Sorry. Get carried away. So what we do is when we find the slope, basically what we're doing is this. Anybody ever travel like to the mountains or anything? We go to West Virginia all the time. At least once or twice a year we go to West Virginia. And through these big old long hills and these real steep hills, you'll have a sign and they'll tell the truckers normally, they'll say steep grade, and they'll say like 5%, 6%, and that kind of thing. Nobody's seen a sign that said that along the road? Huh? You've seen it? Yeah, if you ever go, well, not in Delaware, you won't, okay, because there's no big hills in Delaware. But if you travel, settle down. But if you go out of state, you go somewhere where there are mountains, like West Virginia, okay, you'll see signs that talk about steep grade, and they'll even have these pull-off places for these trucks. You ever see this emergency pull-off? Have you seen that before? Like you're going down this hill, right? And it's really, really steep, and then they have this emergency pull-off thing, and it's kind of like an exit, but it's just gravel. It's just sand and gravel, and it goes off the road, and actually it goes down, but then it goes up real, real steep. So those truckers, if they lose their brakes, because a lot of times they could lose their brakes going down those big hills, and if they do, they won't have a runaway truck. And so they hit those runaway ramps, and they hit it, and they say that it really tears up the truck like crazy because there's so much friction and there's so much sand and rocks and dirt and stuff like that, where it stops it pretty quick, but it rips up the truck. But that's better than killing the driver, I guess. So anyway, that's kind of neat. But they have these well, the fact that you can save a truck driver by these runaway ramps, and they think about the guys, like that. So it's probably not a good thing, but I always thought it'd be kind of cool to actually see a truck go in one of those. And all the years I've driven in West Virginia, I've never actually seen it happen. But yeah, there probably is. I'll have to look it up. So what do they say? They talk about 6%. What are they talking about? They're talking about how steep the line is. All right, and what they're doing is they're making a comparison. They're making a comparison. They take 2 points along that road, okay, where that slant is. And what they're doing is they are comparing how far across you go to how far up and down you go. I know it's not very straight, but okay, so how far across you go compared to how far up and down you go. So look at this. The across right here is way bigger than the up and down. Would you agree? All right, so let's see if I can do this. Let's change it and make it go like that. Now look at it. And since you didn't like my squiggly lines, I'll make a straighter line. Now compare it. Now look. See, from here to here. Now this line right here, it's not as long as this one, but this one's longer, isn't it? So what's happening? The longer one, or the up and down one, the vertical one, is getting higher and higher. So the higher the vertical one is, the what? The steeper the slant of this hill is. Would you agree with that? So it all depends. Now, it could be slanting the other direction. So that's basically what slope of a line is. It's how steep a line is, how much it's slanted. All right, that's the slope of a line. So let's just do some actual things here. And you've probably talked about this before, but let's say here's a nice line right here. We'll make this another color. What color will we use? I've never used that color before. Oops. So let's, and then let's do this. Yeah, it's an orange color. It's beautiful, isn't it? So watch this. What I'm going to do is I'm going to find the slope of this line. So I'm going to go from one point to the other. Now you don't have to go from the very first point to the very last point. I could have gone from this point to this point. Look, is it any steeper along here than it is from here to here? No, it's the same steepness, all right, if you want to use that word. It's the same steepness all along this whole entire line. Would you agree? All right, it's not like it's curving down and it's going back up. It's a nice straight line, so you get the exact same steepness from one line to the other. So what we're going to do is we're going to find out how high do you go. Oops, let's try that again. I'll let up a little early. Does that look like it hits right there? It's close. How high do you go compared to how far across you go? All right, let's drop this down just a tad. All right. Now, in Algebra 1, you probably learned this. Instead of saying how high you go, what do we say? What word do we use? The rise, right. So we compare the rise to the what? To the run, all right? So to find how steep it is, that's what we do. We take the rise and we compare it to the run. Now, I heard you say it already because this is a very common thing in math. We find the rise and we compare it or put it over the run. So it's a comparison. It's a ratio, isn't it? It's a fraction. We compare the rise to the run. That tells us something about how steep that line is depending on those numbers. Make sense? All right. So the smaller that this fraction is, the less steep it is. The higher that fraction is, the more steep it is. All right? But we don't call it steep or steepness. What do we call it? The slope. All right. So the slope is the rise over the run. Now let me do this real quick. Now we learned a little formula. Now rise over run is a great thing to remember. Let's there we go. Let's just move this. Oh shoot. Sorry. I'm killing this thing. Let's just get rid of all of this. Oh goodness gracious. I put this too close to that dumb triangle. So anyway, watch. The slope is equal to the rise over the run. Alright, should have done that in the first place. But let's do this. Let's talk about... Actually, let's get rid of this whole thing. Might as well just get rid of it all. Get rid of that dot. Get rid of this dot. Sorry. Little... Let's do a little X and Y axis deal here. Alright. Alright, so now watch this. What if, oops. What did I just do there? I didn't want that. Oh, goodness. I am. I'm like all crazy today. What's going on? Okay, line. That's what I wanted. How did I get that box anyway? So there's my nice line right here. Watch what we're going to do. Take 2 points on this line. It doesn't matter what 2 points. You could pick the end points if you wanted to. We'll just pick the end points just for fun, okay? But you could pick any 2 points on that line whatsoever because it's not any steeper from here to here as it is from the bottom all the way to the top, is it? So I could pick any 2 points that I know on that line. Let's say we don't know that point right here. We didn't mark it off, so I don't know exactly where that point is. We've done this before, haven't we? Called it x1, y1. So if I call this point 1, we'll call this x1, y1. So what would I call this point up here then? If I call this, yeah, we'll call it x2, y2. All right. Now, instead of just saying rise over run, let's get a little bit more mathematical with this. So let's take this. Let's figure out how far we have to rise. Is that about it, right? And then how far we have to run. That was off a little bit. Let's bring this up to about right there. Okay. Now let's think about this. Let's think of what this point's going to be. Now, how did we get to this? We went over x2. We went up y2, didn't we? So what's this first part going to be right here? How far over did we go to get up here? We went x2, right? So how did we get to this point? We went over what? x2, didn't we? Now, how far down did you go? You went y1, right? Because you went y1 to get down to here, so you went the same distance here. So that would be y1. Does everybody see that? All right. See, how did I get to this point? I went over x2, right? And I went up, what? y2. See that? How did I get to this point right here? I went over x1, and how far down did I go? y1. You see it? So this point right here is at y1. This point right here is at x2. So how do I get to this point? I went over x2 and I went down y1. Alright, you can put regular numbers in there. Might make a little more sense, but there you go. It's not that big of a deal. what do I want to do, though? I want to find this. I want to find that distance, don't I? All right, remember how to find distance? We did this earlier in the other chapter. How do I find the distance between 2 points? What do I do with those 2 points? I just do what? Well, it's not. But this is just vertical, so I don't have to use the whole entire formula. If this was like 7 and this was -2, how would I find the distance between them? I would do what?
y2 minus y1.
I would just subtract. That's right. So look at this. So how would I find this distance? I would just go y2 minus what? y1. Do you see that? And how do I find this distance from here to here? I'm going, here's x1 and here's x2. So how do I do that? I go x2 minus x1. It actually doesn't matter if I put the 1 or 2 first. It doesn't matter the order that we subtract them in, as long as we subtract them in the same order. Okay? All right, so it doesn't matter if I go y2 minus y1 or y1 minus y2. All right? So now, what did we say? This rise over run thing. I'm doing this for a reason, because I'm coming up with this nice little mathematical formula for us. Okay? So the rise over the run, what is the rise? This is the rise, isn't it? What distance did we rise? y2 minus y1. Which distance did we run? x2 minus x1. And right there is our formula for the slope. Right? I don't know if a teacher has explained that to you before on why it was this. Do you remember seeing y2 minus y1 over x2 minus x1? Yeah. You've probably seen that before. I don't know if they've explained where it came from, but this is exactly where it came from. You understand rise over run, so it kind of makes sense. This y2 minus y1 is the y distance, isn't it? It's the y distance from one point down to the other, and this is the x distance. So you put the y over the x. Now, here's another thing. I don't know if they showed you this in Algebra 1 or not. I'll show you a little Greek. All right? All right? Kind of looks like a triangle. It's supposed to look like a triangle anyway. If you look in the book, I think, I don't know, I forget what side, but one of the sides is kind of like darkened in just a little bit. Okay? I don't care. I'm just going to write it as a triangle. But this is a Greek letter of the alphabet. It's called a delta. It's in the Greek letter. Okay? I used to use this little story, and people got it, but now you don't because I'm so old now. But back, probably shouldn't tell you, but on Saturday Night Live, anybody watch Saturday Night Live? You probably shouldn't watch it. It's not even funny anymore. It used to be funny way back in the day. But they had every once in a while, but hardly any. It's just kind of lame now. But anyway, back in the day, it was kind of funny. But they had this little skit where they had these like sorority girls living in a sorority house, and they were all chipper and stuff, and they had their little sweaters on with their little, their Greek letters on their shirts and stuff like that. And the girl was like, she would answer the phone, so it'd ring, and she'd be bouncing all around, all happy, and she'd answer it. And her sorority was called Delta Delta Delta, and that was her sorority. So she would answer the phone. Delta, 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 may I help you, like that. And so that was like, she did that every single time they did that skit. So just like, in your day when something happens on TV, people repeat it in school and you say it over time, and that's what they did. So back in, I forget when that was, it was probably like the middle to late 80s, I guess, somewhere around then. Everybody would say, Delta, 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 may I help you. So maybe you can start a new trend now, and people won't know what you're talking about. But that's a delta, okay? It's a Greek letter of the alphabet. It means the change in something. So what do we say is this, delta y over delta x, or the change in y. Okay, it means the change in. The delta means the change in something. So it's the change in y over what? The change in x. Notice, it's y on top, x on the bottom. A big problem that students have is switching it up. They think x always is first, right? So x is on the top. But it's not, because it's what over what? It's rise over run. Which direction does rise go? Up and down, the y direction, exactly, okay? The rise is in the y direction and the run is in the x direction. Make sense? So remember, rise over run, change in y over change in x. The reason I'm showing you all this stuff is because at some other point, you'll have teachers, professors in college and stuff like that that'll use this delta stuff, and at least you'll say, oh yeah, we did that when I was in geometry class, okay? And he had that stupid story about those dumb girls saying delta, 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 okay? So hopefully you'll remember that. All right. How do we use it? How do we find the slope? This is what they're going to do. They're going to give you 2 points. Sometimes they might give you a graph like this, and they'll actually, tell you what, let's make up. Let's go blue. Let's make up a couple points. What do you think? Where do you think this possibly could be? Maybe like 3, what? 5? Let's go maybe 6. So we say that's 3, 6. What do you think that point is? Probably negative what? Negative 6, what? Negative, let's do a different number. Let's just go 2. That looks a little shorter than that. Yeah. So let's go like that. Okay, so there's our 2 points. So they could give you problems where they actually give you a graph and say, what's the slope of that line? So what you have to do, you got to find 2 points on that line. All right? So here's 2 points that I know. That's 3, 6, and that's negative 6, negative 2. So let's write them down. 3, 6, put them right next to each other, and negative 6, negative 2. Now, we've already had a couple problems that look very, very close to this. What were those 2 problems asking us for before? Find the what? Midpoint or find the distance, right? But this time they're going to say find, what do you think? The slope, right? They're going to say find the slope of the line that goes between these 2 points, all right? So we just have to be able to find the slope. Oh, I almost forgot to tell you. They have a letter, and you probably know this already. They give you a letter that represents the slope, and you'd think it would be S, wouldn't you? But it's not. What is it? It's M. Why in the world M? Okay, yeah, it's actually, I've looked it up. It's actually, they don't know for sure. They're not 100%, but this is a theory. Yeah, it's a theory that it comes from a Latin word, and the word mountain comes from this Latin word, blah, blah, blah. It goes way, way back, and that's one theory. There's several different theories on where the M comes from. Listen, please. But one of them is the M for, it has to do with mountains. It doesn't really stand for mountain, but if that, because a mountain has a high slope and stuff like that. So anyway, that's where they get the M from instead of S. All right, so slope. So find the slope. So what is it? It's the change in y over the change in x, isn't it? Let's just write it out since we're doing it for the first time here anyway. All right, so there's our slope. Let's plug the numbers in. Now again, it doesn't matter what order you subtract. It doesn't matter. As long as you subtract the y's and the x's in the same order. All right, so I could go the first one minus the second one if I wanted to. All right, it doesn't make any difference. And sometimes I like to do that. I like to go the first one minus the second one. Let's do that. So it's going to be 6 what? Minus, not 2, but negative 2. 6 minus negative 2. You see that? I'm taking the y's first. Over, right, and it'll be plus in a second. We'll do that in a sec. And then what's the next one? 3 minus what? Negative 6. All right? What's that? That's 8 over 9. And that's your slope, 8 over 9. Do not turn that into a decimal. You hear me? Do not put that in a calculator and give me a decimal. Okay, slopes are much, much better as a fraction. If it happened to come, what if it came out to 9 over 8? Do I write it 1 1/8? No, because I want to see which one is the rise and which one is the run. If I write it as a mixed number, I can't really see that, can I? All right, I want to see it as a fraction, one single fraction, not a mixed number. Okay, but you should reduce it. You should always reduce it if you can. All right, bro.
What if the slope ever go the other way?
Yes, it will. We'll talk about that in about 2 seconds. Yep, I'm going to talk about that right now. Okay? All right, so that's 8/9. And what's the sign of this? It's positive, isn't it? Now, I want you to see something about this slope. Some books do this. They'll put, watch my cool little car right here. There's my car. It's like a spaceship on wheels. I don't know what it is.
That's awesome.
Look, yeah, that's about my artistic ability right there. Okay, I'm terrible. But anyway, watch. If you're starting right here, listen to me now. If you're starting from the left, okay, because we read left to right, don't we? All right, in English anyway, we read left to right. So from left to right, is this car or spaceship? Is it going up the hill or down the hill? It's going up the hill. So if it's going up from left to right, if it's going up, we call this a positive slope. All right, so this is a positive slope. What time do I got? 20 after. Oh, I only got about a minute left. I'm taking way too long on this. So what if let's just do this. I'll do this super quick here. What if you had a line going like this? From left to right, it's going down, so that's a negative slope, isn't it? That's a negative slope. Man, I wish I would have been able to finish. Watch this. Oops. No, no more cars. Watch this. What if it was horizontal? What kind of slope is that? Yeah, write it down. I don't have enough time to write it down. You write it down. That's a zero slope. Zero slope. I have a nice skiing story for that, but we won't have enough time for it. Maybe tomorrow. Okay, good. What? Thanks a lot. What's wrong with my stories? All right, what about this right here? This is I got a good repelling story for this one. Okay, you have to ask me sometime. This is undefined or it doesn't exist. Okay, or what? Null set, is that what you said? Or no slope, right. We say sometimes no slope or it's undefined. Okay, that doesn't have a slope at all. And we'll talk about that a little bit later. No, it'll just come out negative. The formula stays the same. It'll just come out to a negative number. Let me give you a few things to work on. I think you'll be able to do most of these. There's a little bit at the end you might not be able to do. Okay? Are you listening? There's a section at the end you might not be able to do. I'm getting ready to write it down. Okay, so it's pages 191, 192. And we're doing 13 to 39, but you're just doing the odds. I don't do that too often, but this time I will. All right, there you go. 13 to 39, just the odds. If it says to graph it, yeah, but if it doesn't, you don't have to. Okay?